Welcome to this explainer. Today we're diving into an anomaly so profoundly strange that it literally challenges the foundational assumptions of our entire cosmos. Okay, let's just jump right in. We are going to examine raw, unsimulated data from the deepest reaches of space, and we'll look at two completely different ways of interpreting it. On one side, we have standard cosmology, and on the other, a completely alternative mechanical framework known as pure pressure dynamics.
Section 1. Rules of the Standard Model.
So, to really grasp why this anomaly is such a game-changer, we first need to establish the baseline of standard physics. These are the tried-and-true rules we've relied on for decades to make sense of the universe, covering everything from planetary orbits to the expansion of space itself. Traditional physics leans heavily on well-defined, perfectly predictable formulas, like the ones for centripetal force and gravity, to explain how things move and pull on each other. Basically, it assumes the universe behaves consistently no matter where you happen to look.
This standard relativity equation for time dilation highlights a really core assumption. Classical models portray a universe governed by totally uniform isotropic rules. And isotropic is just a fancy way of saying that, on the largest scales, the universe should look and behave exactly the same in all directions. In standard cosmology, there's absolutely no such thing as a cosmic up, down, left, or right.
The whole idea is summarized perfectly by this quote from Sean Carroll's Introduction to General Relativity, where he points out Hubble's linear relationship for cosmic expansion. You see, standard cosmology is built squarely on the cosmological principle. That's the assumption that the universe expands uniformly like a homogeneous, randomly scattered void. But what exactly happens when live satellite data tells us something completely different?
Section 2. The Axis of Evil. Well, that brings us to a glaring cosmic anomaly that throws a massive wrench into this perfectly uniform model. In the astrophysics community, it's jokingly, but also kind of nervously, referred to as the axis of evil. So the cosmic microwave background, or CMB, is basically the residual thermal energy field left over from the very early universe. When satellites mapped out these temperature fluctuations, scientists fully expected to find a completely random, noisy distribution. But instead, they found a massive structural alignment, a preferred plane stretched across the entire sky. According to the cosmological principle, this absolutely should not exist.
And honestly, here is the part that really threatens that core idea of a random isotropic universe. This highly organized alignment points inexplicably toward the plane of our own solar system, the ecliptic alignment. It's not just some structured anomaly floating in a supposedly random void, it is an organized structure aiming right at us.
Section 3. Running the matrix. To figure out the actual mechanical reality here, we can't just rely on standard model curvature assumptions. Instead, an empirical test was done where a script was run pointing a singular value decomposition matrix right at this exact celestial coordinate. At first, the script tried to connect directly to the primary NASA archive endpoint, but incredibly, it hit a locked HTTP 404 error, not found. So it bypassed that entirely and rerouted directly to the Planck 2018 hardware stream. It extracted the bare metal, physical thermal pressure fluctuations right from the live satellite streams. We are talking about unsimulated empirical macrostructure records of the cosmic boundary at the largest possible scales. This successfully pulled down 7 empirical records of the low-multipole matrix structure, which you're looking at here on the raw temperature fluctuation values mapped across massive cosmic scales. It starts from a multipole L of 2.0 with a power spectrum value of 225.895 and runs all the way down to 8.0 with a value of 615.846. Let's translate this technical math for a second. When we talk about spatial dimensions, these low multipoles essentially represent the overarching mechanical forces of the entire universe. L equals 2 is the quadrupole, which represents overarching 2D compression. L equals 3 is the octopole, representing 3D shear. Now remember, according to standard theory, these components should be entirely randomly oriented.
Section 4. 100% SVD dominance. The script took all this raw data and ran it through that singular value decomposition, or SVD, to really isolate the true pressure tensor alignment. And the mathematical result? It's literally stunning. It begs the question, what actually happens when we strip away all the local noise and isolate the exact alignment of this cosmic thermal field? Do we see a random, multidirectional scatter of energy, like the standard expanding void models predict we should?
The answer is a definitive, unarguable mathematical absolute. Mode 1 of the singular value spectrum carries a pressure energy weight of exactly 100%. To put those numbers in perspective, the primary Mode 1 singular value comes out at a massive 2383.71, absorbing literally 100% of the energy weight. Meanwhile, Mode 2 sits way down at a completely negligible 6.77, carrying a 0.00% weight. In continuum mechanics, this level of complete dominance means there is absolutely zero random scatter. There is no isotropic background expansion happening in this data. The energy is entirely, 100%, locked into a singular unidirectional mechanical axis.
Section 5. Pure Pressure Dynamics.
This raw empirical data directly supports an alternative framework called pure pressure dynamics. It's a model that actually tries to explain the undeniable mathematical reality of what these satellites are measuring. Under this framework, we examine the principal stress axis couplings. And guess what? Mode 1 couples almost perfectly at negative 0.999986 to the power spectrum. The math cleanly strips away all the background noise to verify that this alignment is acting as a singular pressure gradient straight across the macro boundary of the cosmos.
And when you look at predictive simulation results based on this exact data, you can see how this theory calculates maximum strain energy density. The primary axis dictates a whopping 94.3% of the variance, with a principal shear angle of negative 144.52 degrees. If you know wave physics, you know that this is just like measuring stress on a physical object. You use these exact metrics, alongside a driving acoustic frequency and coupling efficiency factor, to figure out the power potential and stored stress energy of a pressurized substrate.
So the absolutely crucial takeaway in pure pressure dynamics is this. The axis of evil isn't some mystical anomaly, and it isn't a quirky relic of a random Big Bang. Instead, it is the primary mechanical pressure conduit of the cosmos. It's the main structural axis where the universal squeeze concentrates its highest laminar shear and directional pressure gradients.
Section 6. A Shattered Universe?
We've looked at the standard rules, and we've just looked at the raw, unsimulated Planck hardware data that completely challenges them. So what does this actually mean for the future of astrophysics? Well, let's objectively contrast the two. On one side, you have the agreed-upon standard cosmology, a universe that is uniformly expanding, isotropic, and looks the same in all directions. On the other side, you have the stark realities suggested by the pure pressure dynamics data, a universe acting as a non-spherical, mechanically constrained pressure enclosure with a highly specific primary structural axis pointing right at our local solar system.
Which leads us to a pretty profound, lingering question about the true mechanical nature of our cosmos. When we look out into the deep field, are we really looking at a randomly expanding void, or are we actually living inside a perfectly tuned, mechanically constrained, pressurized enclosure? It is an incredible piece of source material to wrap your head around for sure. Thank you so much for joining me for this explainer, and remember, keep questioning the cosmos.